A loan officer at a bank has $78,000 to lend and is required to obtain an average return of 9% per year. If he can lend at the rate of 12% or at the rate of 7%, how much should he lend at the 7% rate in order to meet the required return? Because we're looking at earned interest from two separate accounts, let's organize the given information using a 3x3 box. The last row of this 3x3 box is always going to be reserved for the financial goal. And in this case, our goal is to earn 9% of the original $78,000 that he has available to lend. And the first two rows are going to be reserved for the accounts that we're going to blend together in order to achieve that goal. Let's let the first row contain information related to the 12% account, and the second row will contain info about the 7% account. The column headers are going to be such that we want to multiply the first two columns together to come up with the third. And although it's not explicitly said, we are looking at 1 year of time, so our column headers are going to be that we multiply the principal times the rate in order to come up with the interest in the third column. So we say principal times rate is equal to interest. Let's go ahead and populate our rate column. In the 12% account, the rate is going to be 0.12, which is that 12% converted to a decimal. In the 7% account, our rate is going to be 0.07. This time, notice that our financial goal was not given explicitly. In this example, we actually are going to need to calculate it, so we'll put our 9% here. And the goal is to earn 9% of the original $78,000 that we started with. Let's go ahead and multiply these two quantities together to see what our financial goal actually is. And the product of these two numbers is $7,020. So let's go ahead and put that value in the position that represents our goal. The strategy here is that we're trying to populate the first two columns so that we can then multiply across to come up with the third column. And that means we're going to need to figure out what to put in these principal positions. This is where we want to explicitly identify our unknown quantities. When we're identifying unknowns, it's always helpful to look to the end question. The last question will almost always be asking you to find some quantity, and that's going to be our unknown quantity. How much should we lend at the 7% rate to meet the required return? And how much should be lent in the 12% account is also an unknown quantity, even though it's not being explicitly asked for. We'll need to find out how the money is split between the two accounts in order to be able to answer the question. But because we're being asked explicitly for the 7% account, it does make more sense in this case to let that one be our x. So when we solve for x, we will have answered the question. Now the other unknown quantity does need to be an expression in terms of x. We do not want to introduce another variable like y. If we had two variables, we would need to solve this using a system of equations, and this example is demonstrating how to solve using a linear equation with one variable. So because we had $78,000 to begin with, the amount left over to go in the other account is that $78,000 minus however much we put in the 7% account. This is what remains to go in the 12% account. So x is going to go in the principal cell for the 7% account, and 78,000 minus x goes in the principal cell for the 12% account. Now we have our first two columns populated, and we're going to multiply across to generate the third column. The third column represents the interest in each of these accounts, and in the 12% account, the interest is going to be calculated by looking at 12% of means multiply the principal in that account, which is $78,000 minus x. So 12% of however much money is in there is the interest that accrues in that account. And for our second row, we have 7% of means multiply the principal that's in that account will also be interest. In order to create our equation, we're going to add these two interest amounts together to generate the financial goal that we were after in the first place. So our equation is going to be the interest earned in the 12% account, which is 12% of the money that's in there, plus 7% of the money that's in that account, is equal to the $7,020 that is our financial goal. Now what we have is a linear equation with one variable, and we can solve for x. We begin by simplifying the left-hand side as much as possible, so we'll distribute 0.12 into this parenthesis. 0.12 times 78,000 is 9,360. 0.12 times negative x is negative 0.12x. We still have 0.07x is equal to 7,020. Now we're going to combine like terms. So we have 9,360. Negative 0.12x plus 0.07x is negative 0.05x. And we bring down our 7,020 on the other side. Now it's time to get our constant terms together, so we'll subtract 9,360 from both sides. This leaves negative 0.05 on the left and negative 2340 on the right. To completely isolate the x, we now need to divide by negative 0.05. So they cancel entirely on the left to leave us with x is equal to 46,800. So let's finish up by clearly stating our answer, which is that the amount that we put into the 7% account is the value that we found to be x. When we take the 78,000 and we subtract what we found to be x, we get 31,200. But since the question asked specifically for how much was invested in the 7% account, this would be our final answer.